Okay, now we will start chemical properties of aldehydes and ketones.
Mom, we already started with it today, right?
Yeah, we have done the reasoning part. Now
Mom,
we will start the reaction.
nucleophilic substitution reaction.
Nucleophilic addition reaction.
Substitution reaction.
No, it is nucleophilic addition in the chemical properties. First reaction is.
Oh, okay. I must have written it wrong.
Mhm.
Okay, mom. Thank you.
All of you have written addition only, na? Or by mistake I have dictated substitution.
No, it's addition only.
Okay. Okay, so the first property which we have started, nucleophilic addition reaction. In that we have discussed कि why aldehydes are more reactive than ketones. Nucleophilic addition reactions. And second, we have done why aromatic aldehydes are less reactive than aliphatic aldehydes. Now we will start with the reactions part. Okay, Arjun, you tell me out of aldehydes and ketones, which is more reactive towards nucleophilic addition reaction?
Aldehydes.
Reason?
Because ketones have two bulkier R groups.
Because of that,
It's difficult for nucleophile to attack.
keyword is not there in the answer. There are two bulkier R groups, so there is a more steric hindrance. The keyword is steric hindrance. Due to presence of two bulkier groups in ketone, there is more steric hindrance. It is difficult for nucleophile to attack. There is one more reason we have done. In ketones, there are two R groups which are electron donating groups. So which increases the electron density on carbon. So it becomes difficult for nucleophile to attack. Okay, now we are starting with the reactions. First reaction is reaction with HCN. See, if I am writing the compound like this, it means it is applicable both for aldehydes and ketones. If it is aldehyde, it becomes RCHO. If it is ketone, it becomes RCOR. So only there is a difference. If I am not writing R and H, it means it is both for aldehydes and ketones. And it reacts with HCN, the presence of base. I will tell you what is the function of base here. Then you will get a product. In HCN, you know that Cn is minus, H is plus. In CO group, oxygen is partially negative, carbon is partially positive. So when you do the reaction, addition takes place, Cn goes with carbon, H goes with oxygen to give you this compound. So there is an addition, H goes with the negative part, Cn goes with the positive part. And this compound is known as cyanohydrin. What do you mean by cyanohydrin? Cyanide group and hydroxy group on the same carbon. This compound is known as cyanohydrin. Cyanide and hydroxy group on same carbon. The question comes, what is the function of OH minus here?
Mom, to neutralize the acidity.
Where is the acidity here, Aniket? Any acidic compound is there?
Mom, like H plus is there. No. Okay, no, but that's going to OH.
And that becomes OH. So what is the function of OH here? It abstracts, now you know that HCN is a covalent compound. It's not ionic compound. So it will not easily break down to give you H plus and Cl minus, Cn minus. So what is the function of OH minus here? This OH minus have a tendency to abstract the H plus from HCN and form water. When it abstracts the H plus from HCN, it generates the nucleophile easily. So it helps to generate the nucleophile Cn minus and makes the reaction faster. Faster means it catalyzes the reaction. So what is the function of OH minus? It abstracts H plus from HCN and generates nucleophile hence catalyzes the reaction. And hence catalyzes the reaction. So this is a function of HCN, OH minus. It acts as a catalyst in the reaction by speeding up the reaction. And how it speeds up the reaction? By taking out H plus from HCN and generates nucleophile. That nucleophile will easily attack on aldehydes or ketones to give you the product. With this reaction, there is small reasoning questions which you have to learn it. This is a first reaction. No mechanisms.
It what's the word?
Abstract.
Abstract.
H plus ion from HCN stylus is properly and generates nucleophile and hence catalyzes the reaction. This is catalysis.
Mom, will it form a compound called isonitrile hydrogen?
No, only cyanohydrin.
Mom, but it's an ambidentate, no?
But it's ambidendant. Always you know that CC bond is stronger than NC bond. So attack, in this case, attack takes place always from C side.
Okay.
Next is reaction with sodium hydrogen sulfite, NaHSO3. This compound is known as sodium bisulfite or sodium hydrogen sulfite.
This is part of nucleophilic addition, right?
Yes, total 5 reactions comes under that. First is HCN, second is sodium hydrogen sulfide. Or it is also called sodium bisulfite. Riti, can you tell me in sodium hydrogen sulfite, what is positive and negative part?
The HSO3 is negative.
Hmm.
And Na is positive.
Good. Na is positive, HSO3 is negative part. Similarly, in carbonyl group, C is positive, oxygen is negative. So when you do the addition reaction, positive part goes with oxygen, it becomes ONA, and SO3H, this HSO3, it goes with carbon to form this product. This is some simple nucleophilic addition. You have to add negative part to the positive side, positive to the negative side. So this SO3H goes with carbon and Na goes with oxygen. But this compound is unstable. This compound undergoes proton transfer. Change the battery. Undergoes proton transfer. Proton transfer means hydrogen and sodium, they will change their position and you will get OH and SO3Na. Proton transfer. So H and Na will exchange its position. You will get OH and SO3Na. And this compound is the addition product. It is crystalline in nature. Crystalline product. So sometimes in question they ask you there is some compound A which on reaction with sodium hydrogen sulfide gives you crystalline product. So it means your given compound is aldehyde or ketone. Ketones with bulkier group. Pradhana, you have to try this answer. Ketones with bulkier group does not undergo this reaction.
Ma'am, due to lone pair repulsion.
Not lone pair repulsion, some other repulsion. If bulkier groups are there in ketone, what does it mean, bulkier groups?
It repels each other.
No, what do you mean by bulkier groups? It means some heavy R groups. Let us suppose there is one heavier R group here, one heavier R group here. And what is nucleophile? Here nucleophile is also very bulky, SO3H. So if you have two bulkier R groups with carbon, is there any space for HSO3 minus to attack on carbon?
No, ma'am.
So there will be no space. So what we call this word as due to steric hindrance. Steric hindrance means there is already, if we are placed to bulkier group, there is already a overcrowdedness around carbon. So there is no space for the nucleophile to attack. So ketones with bulkier groups does not undergo this reaction because of steric hindrance.
Ma'am, won't that be true for reaction with HCN also?
No, HCN means CN is a very small nucleophile. That is true, but उसमें इस case में bulkier group means if you have two ethyl groups also with ketone, then also this reaction won't happen. Let us suppose you have pentane 2-on, in which CO both sides are ethyl groups. Then in that case also this reaction won't take place due to steric hindrance. Only with very small group methyl groups, this reaction takes place for ketones. In detail,
It's like one more question though. Like, isn't R like an electron donating group?
this electron donating group, yeah.
Yeah. So then won't that give electrons to the positively charged carbon?
Correct.
So like, how will HCN react then?
No, in ketones,
Yeah.
its reactivity as compared to aldehydes is always less. That we have discussed last time, na? Aldehydes are always more reactive than ketones, whether it is a reaction with HCN, sodium hydrogen sulfide, any nucleophilic addition. Aldehydes reacts faster, ketones react slower. The reason is this one only, which you have told. Okay, there are two R groups. Due to that, the positive charge on carbon is reduced. It is difficult for nucleophile to attack, but still under some conditions nucleophile attacks and you get the product.
Okay, fine.
Difference is there in the reactivity, but it reacts both aldehydes and ketones. And this case mein why we have specified this thing, because in this case your nucleophile is very bulky. So even ketone with 2-3 carbons or 4 carbons, that won't react with sodium hydrogen sulfide due to steric hindrance. Now third reaction is reaction with Grignard reagent that you have done in the previous chapter also. Shivani, what is Grignard reagent?
RMGX.
Yeah. Reaction with Grignard reagent, which is RMGX. So in this reaction, you have aldehyde or ketone. Let us suppose first I am taking formaldehyde, HCHO. Its name is methanol or it is called formaldehyde. Reaction I will show you, remaining two you have to do. If it reacts with any Grignard reagent, Bhumika, you know the positive negative charge in Grignard reagent? Which
MgBr is negative.
magnesium is a
Sorry, it's positive and then CS3 is negative.
magnesium is a metal, so it is positive. MgBr is positive. CH3 is negative. Here this one. So when you do the reaction, CH3 goes with carbon, MgBr goes with oxygen. And when you do the hydrolysis of this compound, upon hydrolysis, MgBr is replaced by H, and you will get OHCH3. Ethanol, and you can say you will get primary alcohol. If you remember, in alcohols you have done this reaction. Formaldehyde gives primary alcohol on reaction with Grignard reagent. Now if you have any other aldehyde, all of you do this reaction and tell me the answer. Same reaction followed by hydrolysis. Aniket, what is the second answer?
Second one. Mom, I'm doing the first one.
Like this one, I'm asking this one means
Okay.
RCH.
Mom, so, okay. I think it would be, yeah, R and then CH3 down. OH.
First, it should be OMGBr.
Yeah, okay. So, okay, fine. So then you use H3O plus.
And one more thing, because today I found I took one test for the other students. They have written directly OH here. If you have to write directly OH here, you have to write here is second hydrolysis. You can't directly write OH without mentioning the hydrolysis part. Half mark in the board exams will be deducted for that. Secondary alcohol. Now third one. It should be same thing. Here it should be CH3. Here you will get OMGBr. If you do the hydrolysis, then Cr, R, OH and CH3. So which alcohol is this? Tertiary alcohol. So Grignard reagent on reaction with carbonyl compounds gives you primary, secondary and tertiary alcohols. And this point is important. Formaldehyde always gives you primary alcohol. If you have any other aldehyde except formaldehyde, it gives you secondary. And if you have ketones, it gives you tertiary alcohol upon reaction with Grignard reagent. Ketones always gives you tertiary alcohol upon reaction with Grignard reagent. So this is the third nucleophilic addition reaction. Write on this one, then I will come to fourth one. First one was HCN, cyanohydrin. Second is sodium hydrogen sulfide, crystalline product. Third is Grignard reagent, primary, secondary and tertiary alcohols. And now fourth one is reaction with alcohols. If you are done till here?
Ma'am, 1 second.
Yeah.
Mom, can you wait 2 minutes?
Yeah. Sure.
For the charge distribution on Grignard reagent, in our alcohols notes we've written that the halogen will have the negative charge in CH3 and Mg is positive.
Tell me again, in Grignard reagent?
Won't the halogen have the negative charge?
Halogen have negative charge, but when how Grignard reagent breaks, because the bond between CH3 and magnesium, MgBr is an ionic compound, Mg and Br, but the bond between CH3 and magnesium, it is a polar covalent bond. So in this case, magnesium, because it is a metal, it should be partially positive and CH3 should be partially negative. MgBr is just like a salt here, positive, negative, but when the bond breaks, it breaks from CH3 and Mg.
Yes, ma'am.
If you are done with the writing part, tell me, I will start with the next reaction.
Mom, I'm done.
Bhumika, done?
Yes, ma'am.
Next reaction is reaction with alcohols. Now, here I am mentioning H and R. Why so? Because here in this reaction, aldehydes and ketones, they react differently. There is a different reactions for aldehydes and ketones. Just mention here, it is only for aldehydes, not for ketones. Aldehydes reacts with alcohol. It may be any alcohol. Now you have to tell me, Arjun, you tell me, alcohols, how does it break? H plus OR minus or R plus OH minus?
Could you repeat?
See, in carbonyl group, this is the positive negative part. So alcohols may, what is the positive negative part?
OH is negative.
OH is negative, R dash is positive.
Yeah.
Aniket, is it correct? OH is minus and R is positive.
Yeah, mom, I think.
It's wrong. Alcohols are acidic in nature. So it's always H plus OR minus. How alcohol breaks? OR minus and H plus. Because alcohols are acidic in nature, it always gives H plus ions. So don't break alcohols as OH minus because it's not basic. It always breaks as OR minus and H plus. So again, the same reaction, negative part goes with positive side, H goes with oxygen. What you will get? CrH with this OR dash, and with oxygen, hydrogen comes. And this reaction takes place in the presence of dry HCl gas. I will tell you what is the function here. Dry HCl gas. And this compound, its very important name is called hemiacetal. This compound is called hemiacetal, half acetal. If you have 1 mole of alcohol, then it gives you a product hemiacetal. But if excess of alcohol is there or 2 moles of alcohol is there, then hemiacetal formed here, it again reacts with alcohol. Water is removed, OH and H. Water is removed and this OH is replaced by OR dash, which is called acetal. Water is removed and OH is replaced by OR dash. So when alcohols reacts with aldehydes, it gives you hemiacetal if there is 1 mole of alcohol, acetal if it is excess of alcohols or 2 moles of alcohol. Now, what is the function of dry HCl gas here? Dry HCl gas, again, it acts as a catalyst and speeds up the reaction. How? Now, first listen, then I will dictate this point. This is aldehyde. So, when you are using dry HCl gas, this HCl gas protonates the carbonyl oxygen. This H plus ions will protonate the oxygen atom. Because oxygen has lone pair, oxygen donates its lone pair to H plus from the HCl gas and protonates it. Due to that, positive charge comes on oxygen. I will repeat. Dry HCl gas protonates the oxygen of the carbonyl group. So oxygen will donate one of its lone pair to hydrogen and it forms a bond with it and oxygen becomes positive charge. Already oxygen is electronegative and positive charge on oxygen makes it more electronegative. So it will shift this bond towards itself. So this bond will shift towards the oxygen atom. Carbon becomes deficient. And if carbon is deficient, it becomes easy for the nucleophile to attack because nucleophile can attack easily at the deficient sites. So I will repeat this point. Dry HCl gas protonates the carbonyl oxygen, which increases the electrophilicity of carbon. Electrophilicity means positive charge on carbon. If positive charge on carbon is increased, then it becomes easier for the nucleophile to attack. clear? You have to write in this way: dry HCl gas protonates.
Mom, one second.
Hmm.
Mom, so here you know the electrons from carbon move to oxygen, right?
Yes, the
How does
not from
oxygen get
carbon,
formed?
like these bonds. These bonds shift towards oxygen because oxygen is electronegative in nature. It already has a tendency to pull the bond.
Yeah,
If you
but ma'am, how is it positively recharged though?
because oxygen, see what is the structure of carbonyl group here? It is like this, right? There are two lone pairs on oxygen.
Okay, so there's an A. Okay, fine.
So oxygen will donate its one lone pair to the H plus ions. So when it donates its one lone pair to H plus, it becomes positively charged. And positive charge on oxygen makes it more electronegative. So it will pull this bond towards itself with a greater force. So the positive charge on this carbon is increased.
Okay, fine.
Now note it down. Dry HCl gas protonates the carbonyl oxygen and therefore increases the electrophilicity of the carbon and therefore increases the electrophilicity. If you feel this word is very heavy, electrophilicity, you can write positive charge. Increases the electrophilicity or positive charge on carbon and makes the attack of nucleophile easier. Makes the nucleophilic attack easy. So again, it speeds up the reaction by protonate the carbonyl oxygen. Due to that, positive charge will come on oxygen, which push the bond towards itself, and carbon becomes highly deficient. Write down this, then we will do the reaction with, okay, then I will do one example, then we will. After writing this part, all of you do this reaction: acetaldehyde plus methanol, excess of methanol, what should be the product? Complete this and I will ask you the product. Acetaldehyde plus excess of methanol.
Mom, can you just directly write it or do you need the steps?
Steps. First hemi, then complete acetal. Shivani, you have to tell me.
Almost done, mom. I was in the intermediate. Mom, I turned on my camera and stuff on mic. 1 second, I'm almost done.
Yeah.
Then auto which. Okay, CH3OH. CH3, CH. Mom, okay. So using dry HCl gas, we'll get on top H, on the side of it OH, right hand side OH, bottom OCH3, and on the left side SCH3. Then
When you
we get we're using CH3OH.
Mhm.
we get C, then there's 4 branches. On top we have H. On the right we have OCH3. I mean CH3, OCH3, and then OCH3.
Very good. Yeah, that is the answer. This is acetal and this is hemiacetal. So like this, you have to do the reaction. And don't get confused in exam if they give you acetaldehyde and alcohol, which reaction. And acetaldehyde, they will give you like this, because now I am writing the compound in this way. It looks very easy. They will give you in this way. Don't get confused. You can write aldehyde like this, and then you can do the addition in the normal way. This is positive, this is negative, and then negative part with it becomes OH and OCH3 with carbon. You can write in any order. So whenever you are doing nucleophilic addition reactions, CHO, you can write C double bond O and H separately. Then it will be easy to show the reaction. The same reaction with ketones. With ketones, what is the product formed? You have two different R groups or same R groups, that depends. Ketones always reacts with dihydric alcohol. Ketones does not react with monohydric. Dihydric means alcohol having two OH group. So ketones always reacts with dihydric alcohol. Dihydric alcohol means two OH group, which is glycol. Its name is ethylene glycol. In this case, reaction is simple. You have to remove water. H2O is removed and you have to combine the remaining part. But just note down this point, ketone always reacts with dihydric alcohol to give you the product. So water is removed. This one bond attaches with this oxygen. The other bond attached with other oxygen. So you will get OO, CH2, CH2 bond. And this compound is known as ketal. Aldehydes is acetal, ketones is ketal. There is only one reaction for ketones, and this reaction all. Sorry.
So when
tell
we
me.
take a ketone and make it react with the alcohol, this is the same thing, but in ketones basically.
It's ketone, but in previous case, aldehydes are reacting with monohydric alcohol like methanol, ethanol, like that. But ketones are reacting with dihydric alcohol, ethylene glycol. This is
Okay.
alcohol with two OH groups like this.
Yes, no, I know what it is. Yeah.
So water is removed and you have to combine the remaining part, but the reaction is same.
Okay, thank you.
And this is a cyclic product. Ketal is a cyclic product. It is also known as cyclic ketals. This is the fourth reaction. One is HCN, second is sodium hydrogen sulfide, third is alcohols. Third is Grignard reagent, you will get alcohols. Fourth is with alcohols, you will get acetals and hemiacetals. Now we have to do the last reaction. Note it down, then I will start the next one. Next reaction has a 7 subparts. It's very easy. Only thing is you have to learn the name of the different compounds. All of you are done till here?
Ma'am, 1 second.
Yeah.
Why don't the ketones react with monohydric alcohols?
There is no as such reason for that. There is no stable compound formed, you can say, if ketones are there.
Yes.
I'm done, Mom.
Now, last one is reaction with ammonia derivatives. Reaction with ammonia and its derivatives, you can write ammonia and its derivatives. I will show you the mechanism first, then we will do with the shortcut method. Shortcut method is very easy. Don't write it first, listen carefully how to do this reaction. It is again for both aldehydes and ketones, so that's why I'm not writing R and H here. First, it reacts with ammonia, NH3. NH3 has two subparts, NH2 minus and H plus. And carbonyl group also is like this. Aniket, tell me what should be the product here?
So will it be like C with NH2
C with NH2, yeah,
and OH?
and OH. This H goes with the negative part, NH2 goes with the positive part. And if you remember, we have done one thing. If there are two OH group on the same carbon, it always removes water. Similarly here, if you have OH and NH2 on the same carbon, it always removes water. Water is removed. OH from here, one H from here. So OH and NH2 on same carbon, it removes water. So water is removed and you will get double bond between N and H. Double bond comes. H2O is removed and double bond comes between C and N. And this is a product formed. So this is nucleophilic addition. First negative part goes with positive, positive with negative. Then water is removed and you will get this compound. Now I will tell you the shortcut method. How we have to do these reactions. This is aldehyde and ketone and this is ammonia. Remove oxygen from aldehydes or ketones and H2 from here. So out of 3 hydrogens, if you remove 2 hydrogens, then what is left? 1 nitrogen and 1 hydrogen. Combine the remaining part. 1 nitrogen is left and 1 hydrogen, NH. So that is the same product. You have to just remove water, oxygen from aldehydes and ketones, H2 from ammonia and its derivatives. And combine the remaining part with double bond. So that is a shortcut and we will do the reactions with shortcut method. But for your knowledge, you should know what is the mechanism of the reaction, why it is nucleophilic addition. Now note it down this point, then we will do the reactions. Just give me 1 minute, I will do that.
No.
No, ma'am.
No, ma'am.
No, ma'am.
Okay, also you can't hear it. Fine.
Now I'm audible.
Yes, a bit.
Yes, ma'am. It's very
Ma'am, it's
low.
like very feeble.
Again, it's low.
Ma'am, it's okay now.
A bit, yeah. It's fine. It's understandable.
Okay, so this reaction, Bhumika, I was asking you, कि if you are reacting this with primary amine, what should be the product? I'm not audible.
No, again, no. You
One.
are. You are audible.
Now it will be better.
Ma'am, now again, you're not audible.
Check now. Can you hear me?
Your voice is very low, ma'am.
Ma'am, yeah, it's very feeble.
Just check once now.
Yes, ma'am, it's better now.
Yes, ma'am.
Okay. Okay. So, Bhumika, tell me what should be the answer for this one?
I think again, NH will be added to
Why
the.
NH? Water is removed, H2O is removed. So, what
Oh,
is it?
oh, oh, oh. C and then N and then R.
R. So, you have to remove water and combine the remaining part. And always the bond you have to show from nitrogen. So, the name of this compound is Gibbs base. It is Gibbs base. Now, next reaction is reaction with hydroxyl amine. If you replace one hydrogen of ammonia with OH group, it's better if you learn the names with correspondence to the ammonia. If we replace one hydrogen with hydroxy group, then it is known as hydroxyl amine. Arjun, you have to tell me what should be the product here.
Will it be NH?
Just check. O is removed and from here H2. What is left?
NOH.
NOH. And this product is known as oxime. Hydroxylamine will give you oxime as a product. Now write down these three, then I will come to the next one. Now next is NH2, NH2. If you replace one hydrogen of ammonia with NH2 group, then it is called hydrazine. NH2, NH2, it is called hydrazine. Again, you have to remove water, oxygen from here, H2 from hydrazine, water is removed, and you have to combine the remaining part. Shivani, what should be the answer?
One second, ma'am. So we take minus H2O.
Mhm.
So we get C double bond N NH2.
And NH2. And this name is hydrazone. In all these reactions, just remove water and combine the remaining part. Only thing is you should know the name of the reactants and products. And it is always better if you learn the name in correspondence to the ammonia. If you replace H of ammonia with OH group, hydroxyl amine. With R group, primary amine. With NH2, hydrazine. Next is phenyl hydrazine. What do you mean by phenyl hydrazine? First, you write hydrazine and then replace one hydrogen of hydrazine with benzene group. Benzene is phenyl, so it is called phenyl hydrazine. Aditi, you have to tell me the answer for this.
C double bond O.
C double
N.
bond.
Oh, C double bond N.
Mhm.
NH and the phenyl.
Yeah. N and H with benzene ring. H2O is removed. Combine and its name is hydrazine is always converted into hydrazone. Phenyl hydrazone. Meaning fourth, fifth, sixth, seventh is related to hydrazine. If we replace one hydrogen of hydrazine with benzene ring, it is phenyl hydrazine. Next reaction is reaction with 2,4-dinitrophenyl hydrazine.
Mom, can we write it as N2H2, like for the fourth one, and
No,
for the
no,
fifth
no,
one?
no.
Oh.
N2H4, N2H2, you don't have to write in that way. Don't write any of these ammonia derivatives in the combined form like N2 or N4. You have to write proper structural way. 2,4-dinitrophenyl hydrazine. Now, in this case also, first you start from here. Hydrazine is NH2, NH2. If I replace one hydrogen of hydrazine with benzene ring, it becomes phenyl hydrazine. 2,4-dinitro means there are two nitro groups at second position and fourth position. It is 2,4-dinitrophenyl hydrazine. This is also called 2,4-DNP. This test you have done in labs also. And this is a test for carbonyl groups. Mainly this question they come in viva in practicals. What is 2,4-DNP? And students give the answer 2,4-dinitrophenol. It's not phenol, it is phenyl hydrazine. Pradhanya, you tell me the answer for this.
So you remove O and then H2 it becomes NNH and then a benzene and then NO2 in second and fourth position.
Yes. So what should be the name of this compound? You have to just convert hydrazine to phenyl hydrazone. In all these three compounds, just you have to convert hydrazine to hydrazone. 2,4-dinitrophenyl hydrazone. Write down this one, then I will come to the last reaction, semicarbazide. Okay. Now come to the last reaction, which is semi-carbazide. What is that? If you replace one hydrogen of hydrazine with amide group CONH2. If first you write hydrazine NH2 NH2 and then replace one hydrogen of hydrazine with amide group CONH2. Now this name is semi-carbazide. Then water is removed, again the same thing, H2O, and combine the remaining part. NHCO and H2. Its name is semi-carbazone. Hydrazine replace one hydrogen with amide group CONH2. Now Aniket, you try one answer. In semi-carbazide, you have two NH2 groups here also and this side also. Can we remove H2 from any side?
Mom, since you're asking me this question, I'll say no.
Okay, why?
Mom, so I think with like CO it'll form a bond. That's why.
Like it's you are close by, so it forms a bond means.
Covalent bond maybe.
नहीं, देखो CONH2 is like this. This is a shortcut we are doing. We are removing the water, but actually what happens? NH2 का जो N है, it acts as a nucleophile. So if you have this compound, its structure is like this. So there are two NH2. Why? Only this will participate in the reaction. CONH2 will not participate. Why so?
Oh, mom, is it due to resonance?
Yes, its answer is resonance. Because the lone pair of this nitrogen comes in resonance with CO group. So when it comes in resonance with CO group, this nitrogen will not act as a nucleophile for the reaction. So that's why only this NH2 will participate. So if you are, and sometimes they will give you the compound in not sometimes, maximum times they will give you in this way: NH2CO NH NH2, and they ask you to write the products. What students generally do, they remove H2 from here. So make sure that CO NH2 remains as it is in the compound. Don't remove H2 from that side which is attached to CO group, because the nitrogen which is attached to CO is in resonance. And due to resonance, the lone pair of nitrogen is not available and it will not act as a nucleophile. I will repeat. This is very important reasoning question. There are two NH2 groups in semi-carbazide. Groups in semi-carbazide. But only one is involved in resonance. Oh, sorry, but only one is involved in reaction because the NH2 which is attached to CO because the NH2 attached to CO is in resonance and will not act as nucleophile. Act as nucleophile. So you have to show with this the resonating structure CONH2. Then you have to show that this lone pair is in resonance with CO. So it becomes CO minus double bond NH2 plus. And this is very important reasoning question. If still this explanation is not clear, tell me, I will repeat. Now the last note of this reaction. This is all about these are all 7 reaction: ammonia, primary amines, hydroxylamine, hydrazine, phenylhydrazine, 2,4-DNP, and semicarbon. Okay, one more thing I forgot to tell here. This is a test for carbonyl group 2,4-DNP. Please mention one thing here. Why it is a test for carbonyl group? Because this 2,4-dinitrophenylhydrazone is yellow or orange PPT. So on adding 2,4-DNP, if you are getting yellow or orange PPT, it means the compound contains carbonyl group. It may be aldehyde or it may be ketone. So please mention here it is yellow or orange PPT. 2,4-DNP test. Now there is last note for this reaction. The note is this reaction takes place at some optimum pH of 3 to 4. This reaction takes place at optimum pH of 3 to 4. Now, why the pH should be maintained between 3 to 4? What happens if the pH is below that? If it is a highly acidic or it is a basic medium, what happens? So why pH should be optimum 3 to 4? Because if the medium is highly acidic, you know that ammonia and its derivatives, they are basic in nature. So if medium is highly acidic, so this will form a salt with the acid and it will not act as a nucleophile for the reaction. And if the pH is basic, then it will not protonate the aldehydic oxygen, and it will not speed up the reaction. Reaction will be very slow. So acidic medium is required for this reaction, but it should not be strong acid. It should be weak acid. The reason is ammonia and its derivatives are basic in nature. So in strongly acidic medium, they can form salt. And if salt is formed, then they are not act as a nucleophile and reaction won't take place. And if pH is greater than 4, if medium is basic, then the reaction becomes very slow because it will not protonate the aldehydic oxygen. So it will not speed up the reaction. So you have to just write if this question comes, if medium is strongly acidic, if medium is strongly acidic, ammonia and its derivatives, because it is basic in nature, derivatives being basic in nature, basic in nature, forms salt, forms salt with H plus and hence will not act as a nucleophile. As nucleophile. So that is why this reaction takes place in the presence of weak acids or weakly acidic medium. This is all about nucleophilic addition reaction. First, chemical properties of aldehydes and ketones. We will revise once, then I will start the next one, reduction oxidation. Remaining all are small ones, only this is a bigger one. And try to learn the reactions of aldehydes and ketones by making a flow chart. Because there are many reactions you won't be able to remember. It's very difficult to learn okay, which reaction is this. So when you are doing with methods of preparation, first draw the flow chart of methods of preparation of aldehydes. Write the naming reactions. Then make the flow chart for preparation of ketones. Then you make a flow chart of chemical properties of aldehydes. So make 4 or 5 flow charts of this chapter. Is it done?
If the medium is basic, the reaction gets slowed down.
Medium is basic, reaction becomes very slow. Because you need acidic medium for the reaction, the same reason as we have done for dry HCl gas. Because if you have an acidic medium, it protonates the oxygen, which increases the electrophilicity of the carbon. I hope all of you are done. Now we will redo all the don't write it, just we will revise it, all the reactions. Nucleophilic addition reaction, the first reaction, I will start from Arjun. You tell me what is the first reaction we have done.
Ma'am, with HCN.
HCN. What was the product name?
Cyanohydrin.
Cyanohydrin. And this reaction takes place in the presence of base. What was the function of base in this reaction?
I don't know, I'm not sure.
You have not written it?
I have.
Tell me,
Is
read
it
it.
it abstracts H plus from HCN
And catalyzes the
or reaction.
reaction. It abstracts H plus from HCN and generates nucleophile, which catalyzes the reaction. Now, second, Aniket, you tell me what was the second reaction?
Mom, can you hear me?
Yeah, I can hear you. Tell
Mom,
me.
reaction with NaHSO3.
What's the name?
Sodium bisulfite, sorry.
Sodium bisulfite or sodium hydrogen
Hydrogen
sulfide.
sulfide.
It gives you which product?
It gives you like a crystalline product, right?
Crystalline product. And why the bulkier ketones does not give this reaction?
Steric hindrance.
Yeah. Third reaction we did with Grignard reagent. Aditi, you tell me.
Mom, formaldehyde gives you a primary alcohol. Other aldehydes give you secondary, and ketones give you tertiary.
Yeah. So this is this reaction where we get alcohols of different degrees. Alcohols. Now next reaction we did with alcohols. Bhumika, you tell me with alcohols. Now this reaction is different for aldehydes and ketones.
Yeah, so with aldehydes, the aldehyde gets added to an alcohol and with the medium of dry HCl gas. And then a semi-acetal is formed with the OH and the other R group.
OH and OR.
And then with the addition of excess alcohol or a dimer, acetal is formed with OR dash.
And with ketones?
So with ketones, it is a dihydric alcohol is used. So ethylene glycol, and then water is removed. So cyclic ketal is formed.
Yeah. And why dry HCl is used in this reaction?
Because it protonates the carbonyl oxygen and increases the electrophilicity of the carbon and makes the attack easy.
Electrophilicity of carbon?
It increases the positive charge and makes the attack easy for the nucleophile.
Yeah. Next is ammonia derivatives. In ammonia derivatives, we did 5 reactions. First with ammonia, in which you get the Pradhane. What is the product formed with ammonia?
C double bond NH.
Yes, its name is imine. Amine is A, it is imine. C double bond NH. Now second, Shivani, after ammonia, what was the second reaction?
Yes, ma'am. It was we added R and H2.
What is the name of this reactant?
Alkyl. Sorry, one second.
Primary. Its name is primary amine.
Oh, I did not write that down. One second.
RNH2 is called primary amine.
Primary amine, we get Schiff's base, which is C double bond NR.
Yes, good. Next one, Arjun, what is the third one?
Is it the hydroxylamine?
Hydroxylamine, it gives you product?
Oxime.
Oxime. Aniket, next one?
Mom, so with hydrazine, right?
Product is?
Hydrazone.
Aditi, next one.
Phenyl hydrazine.
What is the structure for phenyl hydrazine?
NH2, NH, and one of the H's is replaced with benzene.
It should be phenyl hydrazone. Next one, Bhumika.
It's 2,4-dinitrophenylhydrazine.
2,4-DNP. Product is 2,4-dinitrophenyl hydrazone.
Hydrazone.
Why this reaction is important? 2,4-DNP.
It's a test for the CO group, the DNP test.
Next one, Pradhanya, you tell me what is the last one?
Ma'am, semi-carbazide.
Structure is
NH2, NH, CO, and NH2.
product form is semi
Carbazone.
carbazone. Shivani, in this semi carbazide, there are two NH2 group. Why only one is involved in the reaction, not the other one?
That is because the NH2 attached to the CO is in resonance and will not act as a nucleophile because it's stable.
Yeah. Next one, Arjun, you tell me why this reaction takes place at some optimum pH of 3 to 4?
Was muted. Its derivative being basic in nature forms salt or H+.
Because ammonia and its derivative are basic, it forms salts in strongly acidic medium. So they will not act as a nucleophile. These all reactions comes under nucleophilic addition. So first you learn all the reactions, then make a flow chart like this, write the name of the reactants and products, and then learn it. I will give you few examples how these reactions they will ask in exams. One minute. There is one example here. This is in-text question in your book. Aniket, you have to tell me the first one. Cyclopentanone plus, it's written like this, HONH2. What should be the product for this in H plus?
Okay, ma'am. So, okay, H2O will go out, right?
Mhm.
Okay, and then it'll be like, one second. NH. Yeah, I'm sorry. It'll be, yeah, ONH, right?
A bond should be with
And
nitrogen.
yeah,
So it should be NOH, not ONH.
NOH. Okay, yeah, ma'am. Sorry,
What
NOH.
is the name here? Oxime. And
Okay,
this
yeah.
compound was hydroxyl. So wherever NH2, NH3, these type of compounds are there, make sure it is ammonia derivatives. They have written like this, OH and NH2. It's difficult to recall which reaction is this. So wherever you are getting NH2 in any reaction, it means it is ammonia derivative. Next is NH2 cyclohexanone, NH2 NH, benzene. Aditi, you have to tell me this one. What should be the answer for this?
On the cyclohexane, double bond, N, NH, and then the dinitro.
Yeah. It's looks complicated, but it's very simple. Again, water has to be removed and combine the remaining part. Now next is RCH, double bond CH, CHO plus NH2CO. Pradhanya, you have to tell me this one. NH, NH2.
Ma'am, so it'll become RCH, double bond H, CH, and then CH.
Hmm.
And then NH2,
Double bond.
a double bond NH2, and then C, NH, and NH2.
Where you have to remove, here you have removed oxygen. From where you
Okay,
will remove H2?
H2, have to remove H2. So become
Which
N
hmm,
NH2 double bond say C double bond O.
what I will write here, C double bond O. Okay,
Yeah, and then NH and N.
NH2. Is it correct? Just cross check, because according to me it's not correct.
Ma'am, no NH2. NH2 is removed.
Where H2? There are two NH2. Which side I will
No, ma'am.
remove H?
Starting C, you should write NH2, then C, and towards the end, H2 is removed.
Then you have to, what you have to do? H2 is removed from this side, right?
Ma'am.
So you start writing from here. It should be N, NH. Then you have to start writing from this side.
Okay.
CO, NH2. Now it is correct. So if you are removing from where you are removing the hydrogen, from start writing from that nitrogen atom. So it should be N, NH, CO, NH2. I hope this part is clear to everyone, because if you are removing H2 from here, that will be wrong. CO, NH2 means this nitrogen is in resonance. So it will not participate in the reaction. You have to remove H2 from the other side. And when you are removing from here, so you have to make bond with this nitrogen and start writing ulta. N, NH, CO, NH2. Now next one, Aniket, you have to try COCH3. I think first one you did. Bhumika, you tell me this one. CH3, CH2, NH2.
So the
Bhumika?
yes, ma'am.
Which compound is this?
1 degree amine.
Remove water and combine the remaining part.
So the okay. To the C, NCH2 CH3 gets attached.
N, CH2, CH3. Baki part as it is, from where you are removing the oxygen, add the remaining part. Water remove karke whatever is left, attach in place of oxygen. What is the name here? Skiff's base. So these reactions, wherever you can see NH2 and aldehyde ketone, it is always a ammonia derivative reaction. So you have to remove water and combine the remaining part with the double bond. And there are two things which you have to see here. If semi-carbazide is there, from which side you have to remove H2, that you have to be careful, because maximum time they will give you in this way only. And the side from where you are remove H2, start writing from that side itself. And in all these compounds, always the bond formed with the nitrogen, carbon and nitrogen bond formed. These all are the reactions. Now I will start with the second chemical property, which is reduction reaction. Now listen carefully, this also, in this there are two naming reactions which are very important. Reduction. Nucleophilic addition is done. Now in reduction reaction, you know that aldehydes and ketones, if it undergoes reduction, it converts into, Aditi, tell me, when aldehydes and ketones undergoes reduction, it converts into which functional group?
Ma'am, for reduction,
Reduction of,
NaAlH4, right?
like it converts into which functional group, aldehydes and ketones?
Carboxylic acid.
That is oxidation.
Oh, that's oxidation. Okay, no, I forgot.
Alcohols. Aldehydes and ketones upon reduction converts into alcohols. Upon reduction, it converts into alcohols. There are two types of reduction we will do, and it can also reduce to alkanes. Aldehydes and ketones can be reduced to alcohols, and it can be reduced to alkanes. Reduced to alcohols reaction we have already done in the previous chapter. Okay, when you use any reducing agent like NaBH4, LiAlH4, or hydrogen in the presence of nickel, platinum, or palladium, CHO converts into CH2OH, alcohol. If you have ketones using NaBH4, it converts into secondary alcohol. Aldehydes converts into primary alcohol. Ketones converts into secondary alcohol. You have to convert CHO to CH2H. Mainly what happens, CHO is like this. So when you are doing the reduction, double bond converts into single bond. One H comes here, another H comes here. So it becomes CH2OH. Similarly, in ketones, double bond converts into single bond. One H gets added on both the sides. Aldehydes primary alcohol, ketones secondary alcohol. It may be NaBH4, or you can use hydrogen catalytic reduction, nickel, platinum, or palladium. Any one of the metal you can use. With this, aldehydes and ketones are converted into alcohols. Is another reaction in which aldehydes and ketones are reduced to alkanes. What is this reaction? These are two naming reaction. One is known as Wolff-Kishner. Very, very important. Highlight this. 99% it comes in exam. Wolff-Kishner reaction. So how to learn this? First, you remember this reaction, if it comes in exam, write Wolff-Kishner reaction. First, you have to recall which topic this reaction comes. It comes under reduction of aldehydes and ketones to alkanes. Now, then you recall the reagents. So, if you have any aldehyde or ketone, you react first step, it should react with hydrazine. What should be the product? It will give you hydrazone, water is removed, you will get NH2, H2 and O is removed, and you get hydrazone. And when you react it with ethylene glycol and KOH, there is a lot to remember here. Then N2 gas is released, nitrogen gas will be released, and oxygen is replaced by 2 hydrogen, HC, H2. You will get alkane. You have to replace the oxygen with 2 hydrogen atoms. If you have propanone, it converts into propane. If you have butanol, it converts into butane. Pentanone, it converts into pentane, like that. For example, if you have ethanol, you are reacting it with, in first step, hydrazine. Second step, you are reacting with ethylene glycol and KOH. What should be the product? Shivani, you tell me. What should be the product here? Ethanol will convert into.
Okay, so it'll. Okay, they just shortcut. So it'll contain. It becomes CH3 plus N2.
See, जो भी reactant है, convert it into alkane, corresponding alkane. Ethanol to ethane, propanol to propane. So corresponding alkane में, और easy way to remember is oxygen को replace कर दो with 2 hydrogens. So it should be CH3, CH3. Corresponding alkane will be formed. Or you can write in short, replace oxygen with 2 hydrogens.
Ma'am, ethane is CH3, CH3.
Yeah.
How?
C2H6 is ethane, na? CH3, CH3. It's like this, na?
Okay,
Ethane
got
structure.
it, got it. Yeah, got it. Sorry, my bad.
Now, if you have propanone, Aditi, you tell me, if you have propanone, you are doing the reaction with hydrazine followed by glycol and KOH.
Propane.
It should be CH3.
CH2, CH3.
CH2, CH3. Propane will be formed. So in Wolff-Kishner reaction, you have to just replace oxygen with two hydrogens. You will get corresponding alkane. If you have butanol, it converts into butane. So this is a reduction to alkanes. And I hope all of you know why I have written 1 and 2 different things, because these are two different steps. So if we are doing the reaction in two different steps, you have to mention number 1 this, number 2 this. Now the second reaction comes under this Wolff-Kishner. After that, Clemenson reduction, next naming reaction. Clemenson reduction. It is same thing. Aldehydes and ketones to alkanes. Only reagent is different. In this case also, oxygen is replaced by two hydrogens. Here we use the reagent zinc amalgam and HCl. Amalgam means alloy of zinc with mercury. Zinc amalgam and HCl. In this case also, oxygen is replaced by two hydrogens. You will get alkane. Let us suppose if you have butanol. Aniket, tell me, if you have butanol on reaction with zinc amalgam and HCl, it converts into Kate, you are here? It's not here.
Ma'am, can you hear me?
I
Ma'am,
can
my
hear you now.
net died.
I can hear you now.
Okay. Yeah, ma'am. What? Clemenson
What is the
reaction,
answer
right?
here? Yeah, Clemenson reduction. What is the answer here?
Ma'am, so
Butanol.
basically, for this, O will get replaced, right?
Mhm.
So will it be CH3, CH2, CH2, CH3?
What is the name?
1, 2, 3, 4. Ma'am, it'll be butane.
Butane. Corresponding alkane will be formed. So butanol converts into butane. So these two reactions comes under reduction. First is reduction to alcohol. You can use normal reducing agent, which may be NaBH4, LiAlH4, or hydrogen in the presence of nickel. But LiAlH4 is not the preferred one because it is a strong reducing agent. Mainly we use NaBH4 and H2. And second is reduction to alkanes. There are two reactions under that, Wolff-Kishner and Clemenson reduction. Both the reactions, reactants, products, both are same, only reagent is different. In Wolff-Kishner, hydrazine followed by glycol and KOH. In Clemenson, zinc amalgam and HCl. Sometimes in MCQ, they can ask you this question, which gas is liberated in Wolff-Kishner reaction? So that is nitrogen gas, N2. Next class, mostly we will finish the aldehydes ketones chapter. Carboxylic acid we have not started yet, but aldehydes ketones we can finish in next class.
Can you explain Clemens reaction again?
See, Clemenson reduction is when you have any aldehyde or ketone. It may be aldehyde or it may be ketone. When you react it with zinc amalgam. Amalgam is alloy with mercury. Zinc amalgam in the presence of HCl. So this aldehyde or ketone, whatever is there, it will convert into corresponding alkane. Alkane means you have to replace the oxygen with two hydrogens. See, like butanol. If you are reacting with zinc amalgam and HCl, butanol will convert into butane. This oxygen will replace by two hydrogen. It becomes CH3. I will give the example, one more example. If you have butane 2 on reaction with Pradhanya, you tell me, if you react with zinc amalgam and HCl, what should be the product?
Mom, so it becomes CH3, CH2, CH2, CH3.
Yeah, it becomes butane. So it is same as Wolff-Kishner. Reactant is same, product is same. In both the reactions, reagents are different.
Understood, Mom.
So revise all the reactions. Methods of preparation. See how many naming reactions we have done. In methods of preparation, there were 4 naming reactions. Rosenmund from acid chloride, if you remember the first class. Stephen reduction from nitriles, Itard reaction from toluene, Gattermann Koch from benzene. There were 4 naming reactions in the methods of preparation of aldehydes. Then we did physical properties, chemical properties. In chemical properties, there are 2 naming reactions in the reduction, Wolf-Kishner and Clemenson. So total 6 naming reactions we have done till now. There are 4 more naming reactions that we will do in the next class. Any doubts still here? No? All of you are done with the writing part?
Yes,
Yes,
ma'am.
ma'am. Yes, ma'am.
Okay. So shall we wind up?
Yes, ma'am.
Pradhanya, 1 minute. Pradhanya, Arjun, Shivani, and Bhumika, you just stay 1 minute. Not Shivani, that Aditi.
Ma'am, can I leave then?
Yeah, Aniket, you can
Thank
leave.
you, ma'am.
Bye.
Bye, ma'am.
Pradhanya and Arjun, you got the marks.
Yes, ma'am.
Yes, ma'am.
You just, it's good or bad?
It's bad.
Bad. Okay. You just message me.
Ma'am, I did too many silly mistakes.
How to improve that?
Ma'am, no, for positive sign, I put a negative sign by mistake and then I lost 3 marks.
Sure.
Huh? You know, for the delta G naught is equal to minus an Fe cell.
Oh, that
I
minus you have not written.
Yeah, I wrote it, but I put in the in the formula I put minus, but when I wrote the final answer, I wrote plus. So I lost marks there.
Okay, so in PTM where you will go now, you just take the pictures of the paper and send it to me, huh?
Oh.
Pradhanya, you also.
Ma'am.
And now you message me the marks, and on PTM day you just take the pictures and send me the photos. I will see where you people are making mistakes in the exams. Okay?
Ma'am,
Yeah. Okay, you can leave both of you.
Ma'am.
thank you, ma'am.
Yeah. Bye. Okay. Aditi, I think you asked me for that thing, na? Coordination compounds, right?
Yes, ma'am.
You have exam. In that exam, it is coming.
Yes, ma'am. It's our term, so like everything we've done with till aldehydes and ketones.
Oh, all the chapters are coming till aldehydes.
Yeah, including aldehydes.
Chemical kinetics, D block, coordination, everything.
Oh, no, not everything. Like everything we finished. We haven't
Okay,
done
except coordination. When is your
coordination.
exam?
It's on Saturday, next Saturday.
Next Saturday. ठीक है. I will schedule 1 or 2 class. I will plan and I will message you. I will give you the brief idea about that chapter. IUPAC naming mainly VBT and CFT. So I will give you an idea about that.
Yes, ma'am.
Okay. Mostly tomorrow is Thursday. Thursday, are you free around 4:30?
From tomorrow. Yeah.
Tomorrow. And then tomorrow we will schedule 1 class. You just remind me at 4 o'clock, huh?
Yes, ma'am.
ठीक है. Then tomorrow coordination के लिए I will schedule 1 class. Fine.
Thank you.
Yeah, bye. Now, Bhumika, what is your status? You also have exam ना? वो किया था
Friday
kinetics
को
revise.
हाँ जी, I did like a few of those questions. तो अभी वो कर पा रही हूँ. I mean, one of them I didn't get. I had to like do it 2-3 times to get it.
One second,
But then
Aditi, if you want, you can leave. She's there. Aditi? Okay, Bhumika, you continue.
yeah, so I did like those questions.